How you doing today? I trust we're all doing fine. So today I have something with me. I have a measuring instrument and we call it the Vernier Calliper. It's called a Vernier Calliper, right? Now this equipment, the Vernier Calliper, is used to measure diameters. It is used to measure diameters. Now, I know some people that use it are people like carpenters, artists, artisans, and so many other different workers, okay? We also use it in the laboratory too. So now, it can be used to measure distance, diameters. For instance, we have a round pen, okay? And I want to measure the width of this pen, so we use a vernier caliper to measure the width, okay, the outer diameter of this circular or cylindrical object. It could also be used to measure the inner diameter, right? It could be used to measure the inner diameter. The inner diameter. That's the diameter inside a cylindrical object. This equipment or instrument could also be used to measure the depth. This part of the vernier caliper can be used to measure the depth of a circular or cylindrical object. It could be used to measure the depth. So those are the things that we do with the vernier caliper. But the new problem we are facing now is not just what to measure, but how to read a vernier caliper. But before we do that, I'm going to talk to us about the different parts of a vernier caliper. Now, this vernier caliper consists of a main scale. This is the main scale. The main scale is a ruler. It's just a ruler which is measured in centimeters. And then we have a vernier scale, which is a tiny scale we see in here, which is measured in 0.1 centimeter. And then we have the jaws that measures the outer diameter of a cylindrical object. And then we have the inner jaws, which measures the inner diameter of the cylindrical jaws. And then we have the tail we use to measure the depth of the object. Then we have a screw, okay? A screw is used to tighten the scale when necessary. So now, let's do a simple exercise of how to read our vernier caliper. Okay, now, assuming I want to measure the diameter of this pen, okay? So I'll put it together. Then I'll tighten the screw. So that it fixes the size, okay? Now, after tightening the screw, we're going to have a reading. This is the reading, okay? This is the reading. Are you seeing the reading? Okay, now this reading, I'm going to draw it out on the board, all right? I'm going to draw it out on the board. So it's usually drawn like something like this, okay? It's usually drawn something like this, right? I don't know if you're seeing this very clearly. It's usually drawn like this, okay? So let's assume we have 1 to 10. 1 to 10. Okay, so this is 1, this is 2, right? This is 3, this is 4, this is 5, this is 6, this is 7, and this is 8. Now this is the main scale. Alright? Then we have the vernier scale. Let's say it's like this. 1, it's always to 10. 2, 3, 4, 5, 6, 7, 8, 9, and 10. Alright? So we'll say, let's call this 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Alright? So this is the vernier scale. And let's remember that the main scale is always in centimeter. It's a scale of 1 centimeter, while the vernier scale is a scale of 0.1 centimeter. It's measured in a smaller scale of 0.1 centimeter. And we know that 0.1 centimeter is the same thing as 1 millimeter. So let's read this example. This is our example 1. Example 1. Right? So now, how do we read this? So first of all, say reading on the main scale. First of all, say reading on the main scale will be what? Right? And then the reading on the vernier scale will be what? Right? So if we look at the main scale, we read where the beginning of the vernier caliper starts. Okay? Where does it stop and where does it start? It stops at 1 on the main scale and starts after 1. So the reading on the main scale will be 1.0 centimeter. Alright? And then, what do we do next? We take the reading on the vernier scale. Now, the reading on the vernier scale has to be where there's an intersection. Where there is an intersection. An intersection between the main scale and the vernier scale. So the intersection happens to be at this point. It happens to be at this point. That is where we have the intersection. So the intersection is at 6. So the reading will be 0.6 centimeter. So what is the total reading or the total diameter? Is the sum of the readings on the main scale and the readings on the vernier scale. So if we add that up, what do we have? We have 1.6 centimeter. So this is how we read our vernier caliper. So let's take 1 or 2 more examples. Another example for us to quickly work on. So example 2. Take the reading. Assuming we measured a small circular ball. What is the reading on the vernier scale? What is the reading on the vernier scale? Alright? So, let us look at this. Let's try something like this. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. 10. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So this is our example 2. So what is the reading on this Vernier caliper? Now, first of all, take the reading on the main scale, and remember, we take the last reading where the Vernier scale starts, and that happens to be on number 4. After number 4, it has to be the reading before the Vernier scale, the last reading before the Vernier scale, which is 4. So we have 4 centimeter for the reading on the main scale, and then the reading on the Vernier scale is at the intersection. Remember, it's at the intersection, and the intersection happens to be at 7. It happens to be at 7. So the Vernier scale will be 0.7. Right? So how do we get the total diameter that we are looking for? The total depth, diameter, outer or inner diameter we're looking for. We're going to add the reading on the main scale and the reading on the Vernier scale, and that is 4.7 centimeter. Wasn't that simple? Maths is easy. Math is very, very simple. So I don't want any of us to have any issue in reading our Vernier scales. Even in your physics practical, you're going to have to read the Vernier scale in some of the questions. So I wish you success and best of luck. And I want to say thank you to my returning subscribers. I want to say I appreciate all of you. Please help me. If you enjoy what you're watching here, please share, like, and comment. Thank you, and God bless. See you in my next video. Bye.